Hello, and today's learning target is I can write and solve a system of equations from a word problem. So we will look at translating word problems into a system of equations and then solving that system of equations. And we've learned a couple different methods on how to solve, so we'll put to use the variety of different methods that we know. So let's take a look at the first example. -3 times one number plus 5 times another number is -11. Okay, so let's write that one out, and we'll call x the first number, and we'll call y the second number. So with this first sentence, -3 times x, so times the one number, plus 5 times another, called the second, so that's y, is -11. Okay, the second sentence says 3 times the first number, so 3x, plus 7 times the other number, so plus 7y, is -1. Find the unknown numbers. So I'm going to use the elimination method because I see that I have a -3x and a +3x. And so I'm going to add together these two equations. And my x's will cancel out, and 5y plus 7y is 12y. 12y equals -12. Divide by 12 here, and y equals -1. Now I have one of the numbers, but I have to figure out the other number. So I'm going to plug that -1 in for y into the second equation and say 3x plus 7 times -1 equals -1. So 3x minus 7 equals -1, and we'll add 7 to both sides. 3x equals 6 divided by 3, so x equals 2. So my final answer here, written as an ordered pair, would be 2 comma -1. And again, I could plug those numbers back into both of my original equations that I started with, and it will work for both of the equations. All right, let's take a look at the second example. The sum of two numbers is -10. -3 times the first number minus the second number equals 2. Find the numbers. So again, we'll call x the first number, y the second number, and let's write our two equations. So the sum of two numbers is -10. So I can say x plus y equals -10. The sum means to add together. Then the second equation is going to say -3 times the first number minus the second number is 2, or equals 2. Now I'll solve this system, and I'll add the two together so I can cancel out the y's. So x plus -3x is -2x. The y's cancel out. -10 plus 2 is -8. Let's divide by -2. So x equals 4. Now I just have to plug that back into either equation. And I'll plug it into the first one and say 4 plus y equals -10. And we'll solve for y. So y equals -14. So my two numbers would be 4 and -14, and that would be my final answer. Now let's take a look at a few real-world examples. Cheryl and Jackie work at the ice cream shop. Cheryl earns $8.50 per hour, and Jackie earns $7.50 per hour. During a typical week, Cheryl and Jackie earn $299.50 together. One week, Jackie doubles her work hours, and the girls earn $412. How many hours does each girl work during a typical week? So let's call C Cheryl's hours, and let's call J Jackie's hours. So for the first sentence, Cheryl earns $8.50 per hour. So I'm going to write 8.5 C plus Jackie earns $7.50 an hour, so plus 7.5 J. And during that typical week, they make $299.50. Okay, now for the second statement, Cheryl will still work her normal hours, but Jackie's going to work double. So I'm going to say 2J, right, because she's doubling her hours. So instead of saying, 7.5 times 2J, let's just multiply 7.5 by 2 right away. And so we don't have a whole bunch of numbers that we have to work with. We'll just simplify that and say 15j equals 412. Now, these systems are set up for elimination, right? Because 8.5c and 8.5c we could subtract, and then that c variable is eliminated. Then I have 7.5j minus 15j to give me negative 7.5j. 299.50 minus 412 is negative 112.50. And if I divide by negative 7.5, I get that j equals 15. So this is saying during a typical week, Jackie works about 15 hours. So now let's plug that back into either equation to solve for Cheryl's hours. So I'll plug that into the top equation and say 8.5c plus 7.5. I have to move all that over. It won't necessarily fit. So 8.5c plus 7.5 times 15 equals 299.50. So I'll have 8.5c equals 7.5 times 15 is 100, is 112.50 equals 299.50. Then I'll subtract 112.50 and get 8.5c equals 187. Divide by 8.5, and you'll see this comes out to be even. So c equals 22. So Jackie works 15 hours, and Cheryl works about 22 hours on an average typical work week. Okay, let's take a look at the next example. A hardware store earned $956.50 from renting ladders and power tools last week. The store charged 36 days for ladders and 85 days for power tools. This week, the store charged 36 days for ladders, 70 days for power tools, and earned $829. How much does the store charge per day for ladders and power tools? So let's denote a couple of variables to represent a couple different items. So we'll call L the cost of a ladder, and we'll call P the cost of the power tool. So with that first equation, the store charged 36 days for ladders, so I'll say 36L, plus 85 days for power tools, and that was equal to $956.50. The second week then it said the 36 days for ladders, and that's nice because our L variables are lining up, and 70 days for power tools, and that had a total of $829. So we want to figure out again how much the store charges per day for ladders and power tools. So I'm going to subtract this system here. So if I subtract 36L minus 36L is 0, 85 minus 70 is 15P, 956.50 minus 829 is 127.50, divide by 15, so P equals 850. So the price of a power tool per day is $8.50. Now if I plug that in to figure out L, I'm going to plug that into, let's do the top equation. So I'll say 36L plus 85 times 850 equals 956.50. 36L, then 85 times 850 is 722.50. We'll subtract 722.50 and get 36L equals 234. Divide by 36, and L equals 650. So the cost for a ladder per day, the store charges per day is $6.50, and the cost for power tools is $8.50. Thanks for listening to the video on writing and solving system of equations. Have a great day. Bye-bye.